Okay, we have a really interesting integral here today. This one was sent to me by Sid, who created some really nice problems, and I'll probably do a few more of these. But to start with, problem number one, we have the integral from minus infinity to 0 of e to the x times natural log cosh of x dx. Okay, to get started, it's a pretty unusual looking expression, but I'm thinking what we can do is do integration by parts on this, because we do that a lot with natural log. But what I can do is if we do that, I can differentiate natural log, and this part's going to be easy to integrate. So let's do the DI method or tabular integration over here to the right. And what I'll do is, like I said, we'll differentiate natural log cosh x and integrate the e to the x. Then first differentiating this, we're going to get 1 over cosh x, and then we need the chain rule, integrate this, we get sinh x. But when you do that, this thing actually is this is just the same thing as tan of x. And then integrating over here, this is just going to be e to the x. So putting this together, we have part of our solution right here on the diagonal. This is just going to become e to the x natural log cosh x. And then we have to evaluate this from minus infinity to 0. And then here, this is going to be an integral. But what I think I'm going to do is, but let's write tanh in terms of the exponentials. So for that, I can write that as, just using the definition, I'll write this as e to the x minus e minus x over e to the x plus e to the minus x. We still have this in front here, dx. Then we'll go ahead and evaluate this first. So first, when x is 0, what's going to happen is e to the 0 is just a 1 in front. Natural log cosh at 0, like cosh is basically this. If you plug a 0 in here, you get 1 plus 1, 2 over 2. So that's just 1. So we have natural log of 1 here, but then that's all going to be 0. And then for this next part, we're going to have to evaluate minus infinity. But then when you do that, we're going to have e to the minus infinity, which is going to 0. And then that's just going to overwhelm whatever this is just going to be. So we could do a limit here, but this is going to be more powerful. So this piece is going to 0 as well. So basically this whole thing is going away. So let me just clean up the board and we can focus on this integral before we finish it off. So now that we have this transformed into this integral here, this shouldn't be too bad. We've got e to the x everywhere. So I think this is going to be good for a u substitution. The derivative of e to the x is e to the x. So I think we're set up with like our du right there. So coming over here, we're going to say u is equal to e to the x. Then for all these e to the minus x's, notice for e to the minus x, that's just going to be 1 over u. Then here, let's take a derivative to get our du value. So du is going to be just this. Du is going to be e to the x dx. So then let's go ahead and substitute. First, take our 0, plug it in there. E to the 0 is just 1. Then take minus infinity. E to the minus infinity is going to 0. Then we have our e to the x value. We have our e to the minus x value. So this is going to become u minus 1 over u, u plus 1 over u du. And then from here, I don't really want these 1 over u, so let's multiply by u over u here. Multiply that in, multiply that in. So when we do that, and let's just expand that out, let's keep this minus sign. Then distributing in here, this is going to become u squared minus 1 in the numerator, and then this is going to become u squared plus 1. Then in order to set this up, it'd be nice if this was a plus 1, right? So let's make this a plus 1, but by doing that, I added 2, so I don't want to change it. Let's just subtract off a 2, and then we'll take this and create this into a separate integral. So then this first integral is just going to be 1. So maybe when we come down here, let's just kind of take care of this. So integrating 1 is going to be u, evaluated from 0 to 1. Then here, minus times minus is plus, so we're going to have a plus 2. And then we're going to have, we still have this denominator, this is going to be du over u squared plus 1. Well, taking care of this first part, the 0 is nothing. We plug in 1, we have minus 1 in front, plus 2. Integral here, this is just arctan. So we have arctan of u, and we just need to evaluate from 0 to 1. Arctan at 0 is just 0, so let's ignore that. Arctan of 1, let's go out of order. This is going to be arctan, here we'll just write down arctan of 1 here, minus 1. But arctan of 1, this is just going to be pi over 4. So we can distribute in this 2 and finish it off. So for my final solution of this, we just get pi over 2 minus 1. Okay, there you have it. Really interesting integral. We'll stop it there. Thanks everyone for watching. Have a good day.